Welcome back, dear friends, and we would continue with the problems on Newton's laws of motion. I plan to solve one numerical applying the Newton's second law of motion. Let me just revise the concepts which we had learned earlier. What we said was the Newton's first law of motion. We said that if the net force is zero, then the acceleration is zero and the velocity is zero. That is, the body would remain in equilibrium. So the problems where the body is in equilibrium, they are to be solved by assuming that the net force is zero and the acceleration is zero. But the second law, they talk about when there is an acceleration, or to be more correct, when there is a change in momentum. So when the rate of change of momentum, as per the second law, is it gives us the net force. So these concepts we have studied, and we said that a special case of Newton's second law of motion, where mass is constant, gives us this very simple equation: F net is equal to mass into acceleration. And we'll be using this equation for solving the problem of connected bodies. So my objective is to solve the problem of connected bodies. In the last lecture, I solved a problem of blocks, three bodies, which in a way were in contact with each other directly. They were in touch with each other. Here we would be also solving the problem of connected bodies, but this time the bodies are not connected by surface to surface contact, but with the help of a massless string. So we'll assume the string to be massless. So let us move to the solving of the problem. Let me go to the whiteboard for solving such kind of problem. Okay. So the problem is as follows. There are three bodies, and the three bodies are let me take the three bodies here. Let us say this is the surface, and there is a body 1. Okay, the body 1 is of, say, a mass of 2 kg. Then there is another body, a bigger body, slightly bigger body. Let us say its mass is 3 kg. Okay. And let us say there is a third body whose mass, this is a smaller body of mass 1 kg. All these bodies are on a frictionless surface. This is our assumption. And they are connected with strings, which are also massless. So this is the assumption for solving this. This is one string, and this is another string. Okay. And this string is facing, this body is pulled from one side, let us say by this body, you are pulling it by one side with some force which is 8 Newton. And the first body, you are applying a greater force. Let us say that force is 14 Newtons. Okay. And we are interested in determination of the tensions in this rope or string. Okay. And how do you solve such kind of problems? So because again, as we had done in the last problem of connected bodies, here we also would assume that the acceleration, because the bodies are connected, so the acceleration of each body would be the same. And I am drawing the acceleration towards the right side. The reason is because you would find that there is more force towards the right. This is a 14 Newton force, and this is a smaller force of 8 Newton. So these three bodies connected with each other, they would move towards the right. So now how do you solve such kind of problems? So step one is, because the acceleration is same, for solving such kind of problems, we always use this expression, that is acceleration, which is same for all the three bodies, is equal to net force upon the summation of mass. This is from the Newton's second law of motion. Newton's second law of motion. Now, what is the net force over here? Okay, so because the acceleration we are talking is towards the right. The acceleration is towards the right. Okay, so the net force towards the right would be 14 Newton minus 8 Newton, because 8 Newton is towards the left. So I'm minus 8 Newton. And the summation of the mass, what are the mass summation? It is 2 kgs plus 3 kg plus 1 kg. Okay, so this gives us 3 plus 2, 5 plus 1, 6, and 14 minus 8 is 6. So 6 Newton upon 6 kg, and this is acceleration, which is 1 meters per second square. Okay, so this is how we determine the acceleration. Now, let us say that you are asked to find this tension T. So this tension T. So how to find this tension T? So for finding this tension T, we draw a free body diagram of this first block. Okay, so I draw a free body diagram for this block, which is of 2 kg mass. Okay, so let us say this is your 2 kg mass on a frictionless surface. So this is the tension T on this, and this is a force of 8 Newton on this. And which side is the body moving? This body is moving towards the right. So applying the Newton's second law of motion, F net is equal to mass of the body 1 into its acceleration. What is the mass? Acceleration is, mass is 2 kgs and acceleration is 1 meters per second square. Okay, and what is the net force? So towards the right, it is, tension is towards the right and 8 Newton is towards the left. So T minus 8 Newton is what we would get. So T minus 8, so T is equal to, this is 2 Newton. This towards the right becomes 8, minus 8 becomes plus 8. So 8 Newton. So the answer is 10 Newtons. So this is how we have to solve this. So we have determined this 10. So this answer is 10 Newtons. Okay. So the steps in solving this numericals are very simple. What you do is that generally you would be asked to find the tension of this strings which the blocks are being connected. And what is the main step? The main step is that the major step in solving the problem is that the acceleration being same, because they are connected body by, and we are assuming that the massless strings are there. So acceleration is same. So we can use this concept for solving the numerical. Okay. And then you draw the free body diagram for the block for which the tension is to be determined, and do the force balance, find the net force, and then apply the Newton's second law, which says that net force is equal to mass into acceleration, and that is how we determine this. So net force would be tension on this side minus 8 is equal to the 2 Newton, which is because kgs into meter per second square is Newton. Okay. And that gives us the tension of 10 Newton. Similarly, you can solve this problem. Suppose you want to find this tension T1. How will you solve this? So again here, we'll have to draw a free body diagram for this 1 kg. And this would be 14 Newtons. And this would be T1. And this is the acceleration A. And here the net force would be 14 minus T1, and the mass is 1 kg, and the acceleration is 1 meter per second square. Okay, so from this becomes 1 Newton. So 14 minus T1 is 1 Newton, and this is how you would get T1 as 13 Newton. Okay, so this way you would get T1 as 13 Newton. So this is 13 Newton is the answer. So these are very simple problems, but you need to remember the steps very well. And the most important concept in solving this problem is that when the bodies are connected, the acceleration is same. Okay. I hope you understood this. Have a good day. Thank you very much.